Dear students, in this video, I'll tell you briefly about atomic number and the mass number. First, what is atomic number? What is an atomic number? You know very well, every element has its own atomic number. For suppose, if you see the example for calcium atom, it has the atomic number 20. This 20, what it indicates, that you have to know. That is only atomic number means since the atom as a whole and electrically neutral, therefore the number of positively charged particles, that is protons, present inside the atom. If you see the picture of any atom, the middle of the atom, the nucleus should be presented. This is the nucleus and these are all the outermost shells, nothing but an orbit. So, coming to protons must present inside the nucleus. And coming to electrons, electrons are present around the nucleus in specific path. These specific paths are called as orbits. And these electrons are located in specific orbitals. So here we can say that the definition of the orbital is the probability of finding the electron around the nucleus in specific orbit, that is called orbital. And coming to here, atomic number indicates the number of electrons present in an atom. So, the number of electrons must equal to the number of protons. That means inside the atom, the presence of protons takes place. Protons are having positive charge. Those positively charged particles must equal to the negatively charged particles. So students, the atomic number of an element indicates the total number of positively charged particles, nothing but protons, equals to the total number of negatively charged particles, nothing but electrons. Let us see the example. Let us take an element zinc. Zinc atomic number is 30. That indicates zinc element has 30 electrons and as well as 30 protons. And another example, let us see fluorine. Fluorine atomic number is 9. That means it has 9 electrons as well as 9 protons. So that is about the total information of atomic number. Next, the mass number. Mass number of an element is equal to number of protons plus number of neutrons. That means protons and neutrons present inside the nucleus. So, mass number we should say basing upon the nucleus. Why? Because protons and neutrons present inside the nucleus. If you see the symbolic representation of the element, Let us see the symbolic representation of the element. That means if you take x, z, a, instead of x you can take any element as an example. In this, a represents the mass number of the element and z represents atomic number of the element. I'll show you with the examples, dear students. Let us see the example. Sodium and chlorine. You know very well the sodium atomic number is 11 and mass number is 23. Like that, chlorine atomic number is 17, the mass number is 35. And sodium mass number 23, atomic number of sodium is 11. By using this formula XZA, you can find out the number of neutrons by subtracting atomic number Z from the mass number A. Why? Because already you know the mass number contains neutrons and protons. Z means protons as well as electrons. These two are same, no? That's why. So if you subtract the atomic number from its mass, we can get the number of neutrons. Let us calculate. The number of neutrons of sodium atom is equal to the mass number minus 11. So 12 neutrons. Like that only for chlorine also, the mass number 35 minus 17, nothing but 18 neutrons. By using this formula, you can calculate the number of neutrons. Presence of neutrons, protons and electrons. Basing upon that, we can calculate the nuclear structure. Nuclear structure. Knowing the number, that means knowing the atomic number and mass number of an element, the number of electrons, protons and neutrons in the atom of the element can be calculated. Already I said about electrons, protons, neutrons. Basing upon these three, we can say the detailed account of nuclear structure. For example, Z represents that atomic number, A represents that mass number, and number of electrons is equal to number of protons. Then this indicates Z. Do you understand? And number of protons, and number of neutrons is known as the mass number. Already I said about that formula, A minus Z. Basing upon this, we can calculate the number of neutrons. Here, one more important point, we can calculate the number of neutrons for ions also. Ions. Already I said the number of neutrons in sodium atom, but here we can calculate the number of neutrons for sodium ion. Sodium ion, that is Na plus. Coming to ions, definition of ions: when these ions are formed by gaining or losing of electrons. When the electron gained and the electron is lost, then the formation of ions takes place. Here Na plus ion has formed. When it is formed, let us if you take the Na atom, sodium atom, the electronic configuration must be 1s2, 2s2, 2p6, 3s1, basing upon the Moeller chart, nothing but Moeller diagram. So, if you segregate this configuration into shells wise, K shell, L shell, M shell. That means K shell contains 2 electrons, L shell contains 8 electrons, and M shell contains only 1 electron. This 1 electron is known as outermost electron. If you draw the diagram for the sodium atom, in the first shell, that is K shell, it contains 2 electrons. In the second shell, that is L shell, contains 8 electrons. In the third shell, that is M shell, has only 1 electron. So, in the sodium atom, M is the outermost shell. Then, for the formation of Na plus ion, sodium has to lose this 1 electron from its outermost shell. Then the configuration should be for Na plus 1s2, 2s2, 2p6, 3s0. That means already this 1 electron has lost. So, we can represent 3s0. Then Na plus has the neon electronic configuration, that is neon 10. By losing 1 electron, that means already that ion has formed, right? So Na plus ion has the electronic configuration of neon. For this Na plus ion also, we can calculate the number of electrons and the number of protons and the number of neutrons also by using this formula. So, for Na plus ion, the number of electrons are 10. Number of protons are same, just like 11, just like Na sodium atom. Clear?